I was going to tell you a joke about sodium and hydrogen to start this off, but nah. Get it? Nah. N A H. What we're going to talk about with this video is sample problem number 5, where we're going from grams to atoms. So gram to atom calculations. This one may be a little bit more difficult because you have to do two conversions. But if you were able to do sample problems 1 through 4, this one is not much different because it's completed the same way, just one extra step. So gold is AU. We start off writing what we know. And let's do our units before we plug in any numbers. We don't want gold, we don't want grams of AU. We want atoms. There is no conversion factor to go from grams to atoms, only moles to atoms, like we just did in sample problem number 4. Now if we look at sample problem number 1, it showed us how to go from grams to moles. So we're kind of combining different things, combining video number 1 and video number 4 so that we can do a two-step conversion. We know that for every 1 mole, the molar mass of gold, looking at the periodic table, gold is AU. It's right here. The molar mass is 196.97. So in here we would write 196.97. And again, we don't want moles, we want atoms. So in order to get moles to cancel, we put that on the bottom. That's moles of AU and atoms of AU. And now it's like the last video where we have to use Avogadro's number. In 1 mole, there's 6.022 times 10 to the 23rd atoms. You multiply across the top and divide by the bottom. And we could take a look at our units that were canceled just to make sure. The grams cancel, the moles cancel. We're left with atoms. And our final answer would be 2.51 times 10 to the 19th atoms of gold. That's a lot of gold. If we look at sample problem B, again I'll do 2 of these for you guys. When you try to do C and D, if you go back and look at some of the other videos, I believe video number 1 will show you how to do if you look at video number 1, I pointed out how to convert from kilograms to grams and milligrams to grams. You may need to know that this is 10 to the negative 3 and that's 10 to the 3rd, the prefixes. So for this one, for B, 812 grams of molybdenum, which is MO. We don't want grams, so we put that on the bottom. We need to go to mole first, and then we cancel out the moles and we go to atoms. And then we plug in the numbers just like we did up above. 1 mole of molybdenum, when we look at the periodic table, we'll erase gold here. 1 mole of molybdenum, MO. Mo. Wally joke. I love that movie. Okay, Mo is 95.96. So when we plug in that number, 95.96, 95.96, over here 1 mole is Avogadro's number of atoms, 6.022 times 10 to the 23rd. We multiply at the top, so 812 times Avogadro's number divided by 95.96 will give us a value of 5.10 times 10 to the 24th atoms of molybdenum. So good luck on those ones. That's halfway through the first set of 10 practice problems. If you have any questions, come see me.